So we were on this question. We were on this question. I think we had drawn the cell, but I'm going to quickly do that again because he's saying draw the electrochemical cell. So I do remember drawing that in the last class, but I'll quickly do this. So draw a fully labeled diagram. You've got this cell and you've got this cell. Whenever you have a metal, you got an AU, which is going to be your metal. So whenever you have a metal and its aqueous ions, the ions would be in solution. It's going to be AU3+. And there would be some sort of reaction that would be happening over here. And there's a nitric acid NO gas. NO gas is going to be in a gas jar. And it would be at 1 atmosphere pressure. And the solution is going to contain this nitric acid over here. That's going to be part of the. So that's going to be part of the solution. So it's going to have nitric acid in it. And its concentration would be 1 mole per dm cube. AU3+ concentration would also be 1 mole per dm cube. And there's going to be a platinum catalyst that's going to be added. And there's going to be a voltmeter that would be between the two. And there's going to be a salt bridge. Okay, so we did all of this in the last class. He asked us to make these electrodes and connect them together, and the apparatus that would be used to measure the E0 cell. So this is the apparatus that's going to be used to measure the E0 cell. I said, Brad, I looked at the notes and my notes are fine. उसमें क्या मसला हुआ है?
जी सर
नोट्स जो थे इलेक्ट्रोकेमिस्ट्री के
हाँ जी
मैं डाउनलोड करता हूँ मुझे तो सही आ रहा है मुझे तो इस तरीके से
एक जी अगर आप वो व्यू करते हैं तो पता नहीं शायद अजीब से एक लाइन आ जाता है उसमें से एक ही स्लाइड है और ना जूम होता है वो और ना इट कैन बी लाइक मतलब इट्स नॉट व्यूएबल
नहीं मेरे तो सही खोल रहा है मैं फोन पे भी खोल के देख लिया बस मेरे तो इस तरह आ रहा है वो देख लो try using Adobe Reader or something I'll check again ठीक है अच्छा but कहाँ पे थे same question ठीक है so the next part of the question is remember we were talking about these two electrodes एक वो nitric acid so he's saying write an ionic equation for the spontaneous reaction that's going to take place. So the higher potential is going to be the one that gains electrons, and the lower potential is the one that's going to be losing electrons. So add up the reactants. Isme the first one, the reactant is AU3+. The electrons are already balanced, and in the other one, the reactants are NO and 2H2O. So it's NO gas. Plus 2H2O. And the products in the first one is AU solid. And in the second one, the products are NO3 -1 and 4H +1. And the electrons gained and lost are already balanced. So no need to do that. And that's your final equation. And he's asking us to calculate the E0 cell for the reaction. So the E0 cell is higher potential minus lower potential. So it's 1.50 volts minus 0.96 volts, and that comes out to be 0.54 volts. So that's that. Now, the next part of the question is that gold can be oxidized by a mixture of concentrated hydrochloric acid and concentrated nitric acid, known as the aqua regia. So gold can be oxidized. So you got gold, and you got a mixture of concentrated nitric acid and concentrated hydrochloric acid. And the concentration is really high. It's 16 mole per dm cube and 12 mole per dm cube. So it's a pretty high concentration. So, and he's saying it's going to dissolve gold. So in your answer, state and explain what effect the use of concentrated hydrochloric acid and nitric acid have on the E values of the half equations 2 and 3. So remember, he's talking about 2 and 3. So we'll focus everything on equations number 2 and 3. because he stated in the question. So it's probably these two equations that are going to be involved. Now, the first thing is he's saying gold dissolves if you got concentrated HCl. And it's a very concentrated HCl. It's 12 mole per dm cube. So it's a highly concentrated HCl. So what's going to happen here? If Cl is concentrated, where would the equilibrium shift? Where would it go if the Cl ions are concentrated?
And backward.
And if it moves to the left, right?
Yeah.
And if it moves to the left, the potential would decrease. So let's give it a hypothetical value. Let's give it that it becomes 0.85 volts, right? I'm just giving a hypothetical value. So remember, whenever the equilibrium shifts in the backward direction, it starts to produce more electrons. The potential on the electrode is going to become more negative because there's going to be a lot of electrons that are going to be produced. So it's going to go in the backward direction if Cl ions are concentrated. इसको label. Right? Is this clear? Alicia, is this clear? Zahib, Bhaskar, clear?
Yes, sir.
And the other one was, it was very concentrated nitric acid. So what would happen if NO3 minus 1, I mean, this is nitric acid, H plus 1 and NO3 minus 1. So what would happen if these two are concentrated? Where would this equilibrium shift? Where would it go? If these two are concentrated, it's going to shift
Forward.
in the forward reaction. It would become more positive. So let's give it some hypothetical value. Let's say it becomes more positive. It becomes 1.20 volts. Now, so you got one potential that decreases and the other potential that increases. If concentrated HCl is there, and if concentrated nitric acid is there. So compare the two reactions now. Who's the higher potential? I mean, previously this was the higher potential, but now the potentials have changed. Remember, these are hypothetical values. I just assumed them, but let's use them. The potentials have changed. This one has become higher and this one has become lower. So the higher one gains electrons and the lower one loses electrons. So the higher one gains electrons and the lower one, it loses electrons. So they didn't have a lot of potential difference to begin with, but now with the changing concentration, the potentials have switched. The lower one has actually become the higher one and the higher one has become the lower one. And there's going to be a reaction. I'm going to write down the overall reaction that's going to happen. AU would turn into, so add up the reactants. The first one, the reactants are these. So it's AU solid plus 4Cl minus 1 aqueous. And in the other one, the reactants are NO3 minus 1 aqueous. Plus 4H plus 1. And the products that you're going to have in the first one is AuCl4 minus 1. And you got NO plus 2H2O. So these are my products. And so gold is dissolving. You had AU solid and it turned into AuCl4 minus 1. So how would you describe that? You're going to state exactly this. It's a 3-mark question. So you're going to state that or you can just quote this half equation 2. I mean, you're going to talk about half equation 2, that the equilibrium, where was the equilibrium shifting in the half equation 2? It was shifting, like Cl minus 1 was concentrated, so it became more backward, so the potential decreased. So you're going to write that equilibrium shifts backwards why if HCl is concentrated and the potential decreases. For the other one, the potential increases. So it decreases and the lower potential gets oxidized or loses electrons. And for the other one, you're going to state the opposite, which is that the equilibrium number 3, it shifts in the forward direction. The half equation number 3 shifts in the forward direction. and its potential increases and becomes the higher potential and it starts to gain electrons. Okay, is this point clear? Why gold will dissolve? You clear? Yes or no?
Yes, sir.
Okay. So remember this point that if equilibrium,
यहाँ पे gold कहाँ पे आया है?
yeah.
कैसे बताएंगे?
कहाँ पे? ये क्या क्वेश्चन था? इब्रार,
ये गोल्ड कैसे डिसॉल्व हो जाती है? आई मीन ये एक इक्विलिब्रियम रिएक्शन पीछे चल जाता है दूसरा आगे. जी जी जी
पहले इशू था कि equilibrium number 2 and 3, which was the higher potential? It was this one, right? 1 volt. मतलब ये पहली वाली इक्वेशन जो है ये तो काउंट ही नहीं हो रही ना. That's not part of the, मतलब he didn't mention it. उसने बस कहा था 2 and 3 को देखो, ठीक है? I mean the question stated 2 and 3. So this was the higher potential, right? तो अगर ये higher potential होता तो it would gain electrons. It won't go in the backward direction. Is this point clear?
Yes, sir.
So why did it go in the backward direction? Because you're using concentrated HCl. And if you use concentrated HCl, the equilibrium shifts in the backward direction, the potential decreases. Remember, whenever an equilibrium shifts in the backward direction, more electrons are produced and the potential decreases. Now it's the lower potential. So lower potential always loses electrons. So which is why it's going to lose electrons. इब्रार समझ आई ये बात?
जी ये दो इन दो इक्वेशन की तो समझ आ गई.
हाँ.
फिर आगे
तो बस यही था ना, गोल्ड डिसॉल्व हो रहा है ना. गोल्ड डिसॉल्व किसकी वजह से हुआ है? कि Cl-1 was concentrated, right?
अच्छा अच्छा जी जी ये
और अगर Cl-1 concentrated ना होता तो ये हायर पोटेंशियल होता ना.
जी 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 हाँ जी.
एंड फिर रिएक्शन फॉरवर्ड जाता, गोल्ड बनता, मतलब डिसॉल्व ना होता. ठीक है.
Yeah.
अच्छा, this one you're supposed to calculate the E0 cell for this reaction. So first thing you have to figure out, okay, what is the reaction that's happening? What are the two electrodes? There's copper 2 plus and there's copper plus 1, I think, over here. तो ये copper 2 plus और copper 1 plus का electrode है, ठीक है? And you've got I minus 1 and you've got I2. I mean, these are the two things that are involved in this reaction. So we'll open the data booklet if we copy. So copper 2 plus and copper 1 plus. So copper 2 plus and copper plus 1 is 0.15 volts. This is 0.15 volts. So we're going to add that. So this is 0.15 volts. And this one is I have to look at the data booklet. The I minus 1, I minus 2 electrode, it's this one, yahan pe. So this one is 0.54 volts. So this one is 0.54 volts. So which what's the potential difference? It's going to be, as a first thing, I mean, for this we would have to first write down everything. Like it's copper 2 plus 1 electron. I have to write, and I have to be careful about this reaction. And the other one was I2 plus 2 electrons, and it's an equilibrium with 2I minus 1. So this one is, the first one is 0.15 volts, and this one is 0.54 volts. Now I have to look at the equation. I mean, look at this equation and figure out where are the two reactions going. Copper 2 plus changes into copper 1 plus. So it goes in the forward direction. And the other one, I minus 1, if you see I minus 1 over here, it changes into I2. So it goes in the backward direction. Now, this is reduction and this is oxidation. So I told you that the E0 cell is basically The reduction E naught minus the oxidation E naught. Okay, although it was the higher potential minus the lower potential, which is the same thing, but remember this, in this case, the reaction is already given. So by looking at this, do you think this reaction is happening in the right way or not? Like, should it gain electrons? I mean, the equation says it should gain electrons. Copper 2 plus changes into copper 1 plus, but look at the potentials. Should it gain electrons, this one, or not? I mean, who gains electrons?
Sir, it should lose.
Okay, because it is the lower potential, right? So the thing is, this equation is not going to happen. Okay, the equation clearly states, okay, there is copper 2 plus over here, and that is changing into copper 1 plus, right? But when we look at the potentials, it should not happen. Copper 2 plus should not turn into copper 1 plus. And similarly, because the lower potential always loses electrons, the arrow should be in the backward direction. So this equation is probably not, it's not a feasible reaction. It's not going to happen. So we can also, if you use reduction potential minus oxidation potential, I'm going to get a negative value, which means it's going to be 0.15 minus the oxidation potential, which is 0.54. And this comes out to be something negative, which is minus 0.39, I think. So the negative value indicates that the reaction is not going to happen in this way. It's actually going to go in the opposite direction. It's going to go in the backward direction. Copper 1 plus is the lower potential. It should lose electrons, and the higher potential, which is 0.54, it should gain electrons. The arrows should have the opposite direction. So this reaction is completely not feasible. And explain how the value of E naught cell predicts that the reaction is not likely to occur. So it's not likely to occur because you're getting a negative potential. So is this clear at this point?
Yes, sir.
Yeah.
Yes, sir.
Okay. Now, so remember, you have to be like, if you're making the reaction on your own, I mean, you would always be right? I mean, हमने पिछले किया था कि when we try to figure out that this is the higher potential, this is the lower potential, I mean, we were the ones who were making the reaction, right? So if we are to determine who gains electrons, who loses electrons, then we would always make the right reaction. But be careful about questions where the equation has already been made for you. So watch out, maybe they did everything incorrectly. Maybe the reaction is not supposed to happen the way they are stating it's supposed to happen. So you have to keep your eyes open if the reaction is already given and you're supposed to check whether it's feasible or not. Just don't go randomly for higher potential minus lower potential. Use reduction potential minus, or make it a habit of using reduction potential minus oxidation potential. Sometimes they're going to trick you by giving you a not feasible reaction. So next one is we have to figure out the copper 2 plus, copper 1 plus potential. So just hold on a second. Just 1 second. So where's this one? So this one, he's asking for the Nernst equation, the non-standard potential. Now he's given you the copper 2 plus concentration, which is 1 mole per dm cube. And he's given me the copper plus 1 concentration, which is 1.3 into 10 to the minus 6, which is a very low value. Now we do know the standard potential. The standard potential in this case is it was 0.15 volts. So पहले तो ये बताओ कि where would the equilibrium shift? Like, look at the concentration. These are non-standard conditions. Would the equilibrium, based on the concentration, would the equilibrium favor the forward reaction or the backward reaction? Which side would it go?
Forward.
Okay, so it's going to go forward, and if it goes forward, the potential should increase, right? It's not going to be 0.15, it's going to be higher. Because the concentration on the right side is very low, so the equilibrium is going to shift. And it's going to move in the forward direction. Okay, जब भी forward जाता है, the potential increases, so it should increase. So how do you calculate the new potential? The new potential is the old potential plus 0.059 divided by Z, which is the number of electrons. And it's going to be log of oxidized. Okay, oxidized is the one that's on the left-hand side, divided by the reduced. So इसको solve कर लेते हैं कि we have the old potential is 0.15 plus 0.059 divided by 1 और फिर log of oxidized कौन सा है? It's the one that's on the left side, so it's 1 mole per dm cube divided by 1.3 times 10 power minus 6. Zaid, can you try and figure this out? What is the new potential that you're getting for this?
Uh, 0.5.
Confirm 0.5 आ रहा है.
Not really. 0.497.
So 0.497. So you're getting 0.497 volts, which makes sense because we figured out that it should increase, right? Remember, जब भी equilibrium forward shift होगा, it should increase, and whenever it moves backwards, there's going to be a lot of electrons produced. क्या चीज?
Copper plus 2 oxidize कैसे हो रहा है?
कि oxidize कैसे हो रहा है?
I mean, formula में तो oxidation और reduction है. Copper 2 plus तो I guess reduce होगा.
नहीं अच्छा उसकी by definition oxidized species the one जो oxidation के होने के बाद बना है. Like copper 1 plus gets oxidized and turns into copper 2 plus. So remember, oxidized is the one that is formed after oxidation. मतलब ये उसकी definition है. But तुम्हारी बात ठीक है, लेकिन the way it's defined is the oxidized species. I don't know why it's defined that way, but the oxidized species is the one that's formed after oxidation. Is that clear?
Yes, sir.
अच्छा फिर ये कि copper 1 chloride is also sparingly soluble in water. Suggest why the following reaction does not occur. So you're saying that copper 1 chloride is also sparingly soluble, so why does this reaction not happen? So in this case, there are अच्छा पिछले के बारे में, what did he talk about the अच्छा, so he's saying that, like, look at the previous one first. So copper 2 plus is coming out to 0.5497, fine. So here he's saying that there's a copper 2 plus 1 electron and it's in equilibrium with copper 1 plus. The other one is the Cl2 equation, which is Cl2 plus 2 electrons in equilibrium with 2Cl minus 1. Now this is 1.36 volts, and that is the one that we just did earlier, so 0.15 volts. So in this case, we're saying the reaction does not occur. Why does it not occur? So again, you just have to explain that he's trying to change Cl minus 1 to Cl2, but based on which one is the higher potential, this is the higher potential and this is the lower potential, right? So based on this, what you're going to state is that the Cl2 or Cl2 Cl minus 1 has a very high potential, so it's always going to gain electrons. So it's not able to lose electrons. The potential difference is too high. मैं इसका पिछले part से comparison कर लेता हूँ. पिछले part में what he's doing is the potential difference is there, and theoretically the reaction does not occur. But the potential difference is not. It's not very large. There's a very little difference between 0.15 and 0.54. Now, listen to this carefully. What he did was that he gave us these concentrations. And we figured out the new potential, which was 0.497, which is approximately 0.5. So what happened over here is, it's jagah pe, this potential kind of became 0.50 volts by changing the concentration, right? And similarly, I think the iodine, he said something about iodine as well. But all you have to do is, you can just increase the concentration of I minus 1 just a little bit, that the potential decreases, and maybe it becomes 0.40 volts. The reaction would start happening, right? The higher potential would gain electrons and the lower potential would lose electrons. Previously, the reaction was not happening. So yahan pe what he's doing is that because the difference is not that much, you can alter the potentials by changing the concentration, which he exactly did over here in this part. He changed the potential and he said that the reaction does occur and a precipitate is formed. So do you get my point? Is this point clear? In reality, there is a reaction that's happening. Zay clear, Brar, Maria?
Yes, sir.
I said, but why can't you do this over here? The reason you can't do this over here is that the potential difference over here is very large. I mean, you can change the concentrations, you can make this a higher potential, but I mean, there's a long way to go. It's like there's a huge gap that needs to be covered. वो उसके अंदर भी यही इशू था, वो जो पिछला क्या था ना कि we did the gold question, right? The potential difference between the two was very, very less. So by just changing the concentration a little bit, you can make this the lower potential and make this the higher potential. क्योंकि उनके बीच में difference इतना ज़्यादा था नहीं. And the same applies to this one. The difference is still not very large. So you can, by just altering the concentration, make this the higher and make this the lower, right? So the reaction will happen. But in this case, the potential difference is pretty large. So you can't really do much. You can't make the lower the higher one. It would be very difficult for you to do that. Okay, so is this clear?
Yes, sir.
So इसका वही लिखोगे, the potential difference is very large, and chlorine has a very high potential, so it would always gain electrons. So it's never going to lose electrons. Now over here he's saying the reduction of chlorate ions with SO2, so I think it's ClO3 -1, and he's reacting it with what? With SO2. And the product is ClO2 and sulfate ions. That's the reaction. As the only products, is there anything else? ClO3 with SO2 forms chlorine dioxide, which is this, and SO4 2-. So that's it. That's the reaction. So you need to balance this equation. Remember, it's a redox reaction. I mean, sulfur over here is +4. I mean, you can calculate sulfur. Sulfur over here is +6. And so that means sulfur does what? It loses it loses 2 electrons. So on the other hand, Cl over here is +5. I mean, you can calculate it's +5. And Cl over here is +4. That means it gains 1 electron, right? Just make sure that calculate the oxidation state. ClO3 -1. So I think Cl is +5. ClO2, it's going to be +4. But anyways, so you've got the oxidation states. Gains 1 electron, gains 2 electrons. So the electrons gained and lost must be equal. So this should be double. So you double this. So that means there should be 2 Cls. And now the electrons gained and lost are equal. And maybe the equation is also balanced. That's 3 into 2, 6. 6 plus 2 is 8. 2 into 2 is 4. 4 plus 4 is also 8. So everything else is balanced. Ye clear?
Yes, sir.
disproportionation कर लो. What is
Yes, sir.
disproportionation? अच्छा ठीक है. It's when the same element reduced and oxidized. So that is what disproportionation is. What about deduce the ionic equations for the half equations for the reaction in B, which is this one. So you're going to find the oxidation equation first. So who's getting oxidized? Cl is +4. And this is Cl is +4 over here. Cl is, what is Cl over here? You can calculate the oxidation state. I think it's +3, I guess. -4 +3, that would give you -1. So this is +3. And Cl over here is +5. So oxidation, who's getting oxidized? +4 to +5. So that is oxidation. So ClO2, it turns into ClO3 -1. What about the reduction equation? The reduction equation is going to be the same ClO2 turns into ClO2 -1. So you got ClO2 turning into ClO2 -1. So that is a gain of 1 electrons. And the other one is a loss of 1 electron. You're going from, your starting point is the same, +4 to +3 and +4 to +5. So I've added up the electrons as well. Now the oxygens are not balanced, so I need to add OH ions over here on the left, because that's the only thing that's left. So I'm going to add, I think I'm supposed to add both OH ions, because, so I'm going to add 2 OH ions, and on the other side I'm going to add water, and let's see if this equation gets balanced. I think it gets perfectly balanced with that, and that's my half equation. One of them was the oxidation equation. हाँ,
आपने ऑक्सीडेशन वाले के साथ OH और H2O क्यों ऐड किया? I mean,
क्योंकि यहाँ पे
reduction वाले
यहाँ पे जरूरत ही नहीं थी ना. एक Cl है, 2 ऑक्सीजन है, एक Cl है, 2 ऑक्सीजन है, बात ही खत्म. The only difference is that it's gaining electrons, right? It's gaining 1 electron. That's it. Atoms ऐड करने की जरूरत तो नहीं है ना इधर कोई.
नहीं तो I mean ऊपर हमारे पास ज्यादा है, बस ऑक्सीजन ज्यादा ऊपर.
नहीं, पहले तो ये बताओ ना कि रिडक्शन में why did I add it? क्योंकि it was already balanced. Why do I want to mess it up?
अच्छा, we're looking at it as separate equation. ठीक है.
ठीक है. I mean you're supposed to, because the OH ion and water has to be added. It's not part of the reduction and oxidation process. Like once you make the half equation, the 2 half equations must add up to give you this, right? So I did the reduction equation, which was +4 to +3, but the atoms were already balanced, so I didn't have to add anything. The only thing is you're going from +4 to +3, so that's a gain of 1 electron. Clear?
जी सर.
और वो दूसरा जो था वो ClO2 turning into ClO3 -1, and so it was going from +4 to +5. That means it lost an electron. तो वो जो water और OH ions है वो फिर इधर ही डालने पड़े थे, क्योंकि the oxygen was not balanced, right?
सर ये उल्टा हो सकता था, ClO2 के साथ वाटर और ये राइट साइड पे OH ions.
हाँ, लेकिन वो इधर हमने तो इसको देख लिया ना कि फाइनल इक्वेशन शुड बी दिस वन, राइट?
हाँ, ये ठीक है.
तो इस केस में वाटर इज ओवर हियर, OH ions are over here. So ये वो क्या कह रहा है? Lithium iodine electrochemical cell can be used to generate electricity for a heart pacemaker. The cell consists of lithium electrode and an inert electrode immersed in body fluids. When current flows, lithium is oxide, iodine is, he already told you that. Use data booklet to write half equations for the reaction taking place at the 2 electrodes. So I think it's a lithium electrode. What is he saying? I mean, you're just supposed to write the equation. He just told you lithium. Where's lithium? Lithium is oxidized. So this thing, lithium is oxidized. So that means lithium will lose 1 electron. I'm not even going to open the data booklet. I know the lithium is in group 1, so it loses 1 electron. And iodine is reduced. So iodine gains, it's going to gain 2 electrons to form. Now, you can balance the number of electrons gained and lost. Okay, that is something you should do because you need to make the overall equation. So this would be multiplied by 2, 2, and 2. Add up the reactants, it's going to be 2 Li plus I2. And add up the products as well, it's going to be 2 Li plus 1. And he's asking you to calculate the E0 cell. I know for this one, it's 1.07 volts. I mean, you can just open the data booklet and the iodine one is 1.07. Where's the iodine one? Sorry, it's 0.54 volts. This one is 0.54 volts. And the other one is, where's the lithium one? Probably, so it's LMN. Lithium is over here, right next to iodine. It's minus 3.04. So it's minus 3.04 volts. So it's a reduction minus oxidation. So this is getting reduced, or higher minus lower in this case, reduction minus oxidation. So 0.54 minus the other one, which is minus 3.04, and you'll get your E0 cell for this reaction. TK, you clear?
Yes, sir.
Or the last part, I think the lithium, assume that the current remains constant throughout this period. So calculate the time taken for. So there's 0.1 grams of lithium that is getting deposited. So lithium plus 1 electron, it's forming lithium. So 0.1 grams of lithium. So how many moles is that? Mass divided by MR lithium is what? 7, I think. So what do you get? 0.1 divided by 7, it's what? KZ 0.1 divided by 7.
0.014.
So you're getting 0.014 moles of lithium, right? So the moles
Yes.
of electrons that would be needed would be exactly the same 0.014 moles, right? So that would be exactly the same. And you can convert that to charge, which is 1 mole of electrons. I mean, you're going to use Faraday constant, has a charge of 96,500. So if you have 0.014 moles, and you're going to find X. And X would be 0.014 into 96, 500 coulombs, right? तो क्या वैल्यू है ये?
1378.6.
अच्छा नहीं क्या 1307
1378.6.
coulombs, right? और फिर वो Q is equal to IT लगा लो. Time निकालना था ना. The current is given. Current is 2.5 into 10 per minus कितना amperes है? 2.5 into 10 per minus 5 amperes. So Q is equal to IT. So 1378.6 coulombs has to be passed through the circuit. So it's going to be current is फिर भूल गया. It's 2.5 times 10 per minus 5. Into time. ठीक है. तो टाइम बता दो कितना आ रहा है टाइम सेकंड्स में.
Um 5.5 times 10 power 7.
अच्छा सेकंड्स राइट. चलो ठीक है.
Yes.
कंटिन्यू करते हैं. कल कोई अगर कोई काम का क्वेश्चन हुआ we'll do those and I've sent the worksheet. ठीक है वो प्रैक्टिस कर लेना. चलो ठीक है. ओके एवरीवन.
Thank you, sir. Allah Hafiz.
अल्लाह हाफिज.